Hello, this is Mr. Huber. In this lesson, we're going to learn about solving inequalities, specifically by using addition and subtraction. Okay? An inequality is where we're comparing an amount to some other quantity, less than or greater than it. Okay? And the graph of an inequality in one variable can be represented on a number line showing all of the numbers and values that are solutions for that particular inequality. So there's a couple of them identified here, written out, and graphed. So we can see here the graph of x is less than 3. That's how it would be written. X is less than 3. So on our number line at 3, we're going to have an open circle. We're going to talk about the difference between open circle and a filled in dot here in a moment. So we'd have a circle at 3, and then less than means we want numbers that are less than 3. Right? This graph here shows all of the numbers that would plug in and make this inequality true. If I take 0 and plug it in over here for x, 0 is less than 3 makes this true. Here, 4. If I put a 4, 4 is less than 3. That's not true. That's why that's not part of my graph of my solution. So my solution is all of these numbers on the number line, even the ones in between these integers, right? 1/2 would be a solution. 1.2, negative 0.8, all right? Negative a million if we keep going. Those would all be solutions of this inequality. And then over here, x is greater than or equal to negative 1. So when we have the equal to, that's when we have a filled in dot. We can see down here. Use an open circle when it's a less than or greater than. When it's a less than or equal to or greater than or equal to, we have the equal sign underneath here, then we're going to have a closed dot. And greater than or equal to negative 1, so at negative 1 we put the dot, and then we have numbers that are bigger than negative 1. Right? The inequality sign, the bigger side of the inequality is where the bigger quantity is. In this case, x is on the smaller side. It's less than 3, which is bigger than x. Here, the x is bigger than negative 1. Numbers get bigger as we go to the right on the number line. So we're going to want to be able to write out and graph these inequalities, and we're going to solve them and then graph the solutions as well. So inequalities can be represented on the number line, open circle or filled in dot. The closed dot is when we have the equal to as well as the less than or greater than as part of our inequality. Let's practice writing out some inequalities to see what the graphs look like as well. So here in Antarctica, so the lowest temperature recorded was negative 129 degrees Fahrenheit. That's pretty cold. At the Russian Vostok station in 1983. Okay, using this fact, we're going to write an inequality that describes the temperatures in Antarctica. We'll use x as our variable for the temperature. So if x would be greater than or equal to negative 129 degrees Fahrenheit. It can be equal to negative 129 or anything bigger than that. And what would that look like on a number line? So we're going to have our number line here, 0 somewhere over here. Then put a couple numbers in. We don't have to label out, 1, 2, 3, 4, 5 all the way down to negative 129. Okay, so we could do negative 50, negative 100, negative 150, and negative 129. Okay, and it's filled in because it's got the equal to right around there. That'd be negative 129. We'll label that, and then on our number line, we're going to have numbers going to the right bigger than that. The temperature would be something greater than negative 129 or equal to it, which is why we have the dot. So write out an inequality that goes with that situation. Know if you want to be greater than or less than the number, and then also whether you can include that number. In this case, we can include the negative 129 because that was a temperature, so that's part of our solution. So now let's write out an inequality for these graphs. So if we look at this graph here, and again, we'll just use x, but you could really use any variable you want. Okay, we'll use x for our variable here. We're going to have x is less than 8. X is less than 8. We have numbers that are smaller than 8 on our graph. And in this next one, we have x is greater than or equal to negative 2.5. Okay, so a couple things to keep in mind. Open circle, so we don't have the equal to there, just the less than or greater than, in this case a less than. Here, closed filled in dot, so we include the equal to. 8 is our point that we're going to have numbers less than it, so the variable is less than 8. Here, numbers to the right bigger than negative 125. When we're solving equations, which we've done before, we can get the variable by itself. We want to isolate the variable, right? To solve an equation, we want to isolate the variable by doing inverse operations. The same thing on one side of the equation, you do the other side of the equation. It's the same for an inequality. When we come down here and we want to solve this, we're going to solve it the same as if this was an equal sign. Okay? We could put an equal sign there, and if I wrote that out as x plus 7 equals 4, and I asked you how you'd solve that, you should know that we'd subtract 7 on both sides to cancel out 7 and get x equals negative 3. Well, now when we're solving it as an inequality, we're going to do the same thing. We're going to subtract 7 on both sides of the inequality instead of both sides of the equation. That's going to cancel out to get the x by itself less than negative 3. So we didn't do anything differently, except instead of an equal sign, we have an inequality sign. And then we can graph that. So if we're going to graph this, okay, we can draw out our number line. So that's 0, and then that's 1, 2, 3, negative 3. Okay, and we're going to have at that point an open circle at negative 3 and less than. So we're going to be going to the left, less than negative 3. Right? In this next example, number 5, negative 3 plus w. So to cancel out the negative 3, we want to add 3. We want to get the variable by itself. So look to the side where the variable is. 9 plus 3 is 12, is greater than or equal to w. If you want to rewrite that, because it might be easier to graph, we could rewrite this as w is less than or equal to 12. These both mean the same thing. Right? The w here is on the smaller side of the sign. The w is less than the bigger side, the 12. Okay? W is less than or equal to 12. And so we can graph that on our number line. That's 0. And then we could put 5, 10, 15. So that's 10, that's 15. 12 is going to be right around there. Okay, that's 12. And less than or equal to, so we have the filled in dot because it's got the equal to. And less than, we're kicking our numbers less than 12. For any of these, you can check your solution. So let's just go back to this one we just did here. If we want to check, we could take any of these numbers that are on our graph. These all should be solutions to our original inequality. So let's take 5. If I want to check and see, I could plug a 5 in here. Negative 3 plus 5 is 2. So I'd have 9 is greater than or equal to 2, right? If I plug in a 5 there, okay, for w equals 5, checking that point. Right, we're checking this point right here to see that that's a solution. We have 9 is greater than or equal to 2. That's true, so that shows me 5 is a solution. I have a good idea that my answer is correct. It's a little less exact when we're doing inequalities, but you can still check by plugging in numbers that are part of that solution set that you've graphed. Let's try a couple more here. And again, you should be trying these, seeing how you're doing on those. So in number 6, we can add 1.7 to both sides. Negative 6.8 is less than or equal to m. Okay, so we can graph that out. When we graph this out, we're going to want a number line like this. That's 0. We'd have negative 6, negative 7. Okay, negative 6.8 is between those, a little closer to negative 7. And we're going to have a filled in dot, so that would be negative 6.8 there. And m is greater than that, so m is on the greater side of the sign. We'd have our arrow going to the right on our number line. All right, our next example, we're going to subtract 1/2 on both sides. Subtract 1/2. M is greater. 3 minus 1/2 would be 2 1/2. So we'd have m is greater than 2 1/2. Again, we could put that on a number line. It's going to be between 2 and 3, right in between them. So there's 0, 1, 2, 3, and 2 1/2. We're going to have an open circle, right, at 2 1/2. And then greater than, we're going to have our arrow going to the right, greater than 2 1/2. So get the variable by itself. Then when you get the variable by itself and you want to graph it, put that point, if there is an open circle or a closed dot, and then figure out if you want to go less than or greater than that number based on what the inequality is and whether the variable is bigger than the number or smaller than the value we have. Before we continue with some inequalities, let's talk about temperature. We had the problem earlier about the temperature in Antarctica. Well, there's different ways to measure temperature, different scales. Like we have inches or meters and different scales for measurements and different things. Fahrenheit is what we commonly use here in the United States, but Celsius is used largely in other places around the world. The Celsius temperature scale, there's also Kelvin and other temperature scales as well, but Fahrenheit and Celsius the most common. The US is one of the outliers using Fahrenheit actually. And there's some different temperatures that convert between the two scales. So for instance, in Fahrenheit, okay, 212 degrees is equal to, in Celsius, 100 degrees. That's the temperature where water boils. Okay, water freezes at 32 degrees Fahrenheit, which is 0 degrees Celsius. So you see the Celsius scale, it kind of makes sense. Freezing at 0, boiling at 100, there's something there instead of 32 and 212. So in any case, we can debate which one might be more practical to use, but Celsius one makes a little more sense there. What temperature is the same in the two scales? Right? What temperature would be the same in the conversion? There's only one. Okay, they're not all the same. Like we see 212 and 100, 32 and 0. So the one temperature that's the same in both Fahrenheit and Celsius is negative 40 degrees Fahrenheit is the same as negative 40 degrees Celsius. The one temperature that's the same in both scales, Fahrenheit and Celsius. All right, let's look at some more inequality here. Let's apply what we've been using here to write out an inequality for this situation and then solve it. you're checking a bag at the airport. Okay, they have a weight limit of 50 pounds. Can't weigh more than that. And right now our bag weighs 16.8 pounds. We're trying to figure out how much we can pack in there. We're trying to get as much as we can for this great vacation. We want to find the possible weights that you can add to the bag. So in this case, right, we have the 16.8 pounds it weighs plus W, the weight that we're going to add to it. We want that to be less than or equal to 50. Okay, less than or equal to 50, because it can be, it says no more than, but it can be 50. So 50 is not more than 50. So in that case, we want to read whether we can be equal to that or not. So since it says no more than, that means we can have the equal to 50 as well. So to solve this now, we can subtract 16.8 on both sides. Okay, and W would be less than or equal to 33.2. So we can add up to and including 33.2 more pounds to our bag. So the weight we can add, right, how much can we add to the bag? We can add up to 33.2 pounds and still not go over that limit of 50. Right? So there we wrote an inequality and solved it for that situation. Right? The one we wrote earlier about the temperatures, there was no variable to solve for, but still recognize, do we want greater than or less than? Are we including the number or not? So do we have the equal to along with our inequality? And then when we're solving these, solve the same way you would an equation. Get the variable by itself using those inverse operations, and then the extra step onto there when we're graphing, look at where do I put my open circle or closed dot, and then draw in my arrow, and you can still check by plugging values back in and seeing if your graph looks like it's giving you values that do solve that inequality.